Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. We are seeing the problems on straight lines inclined to both the planes. And in the previous video also, we have seen one typical problem, right? Same type of problem we can do in the other way also. Let us see. When a line is making angle with both HP and VP, and if it is the sum of these angles is 90 degrees, we have seen one way of solving in the previous video. Now, this line, when the sum is 90 degrees, the line will be in the profile plane, which is perpendicular to both HP and VP. Okay, but without seeing anything or with the side view, we can also solve this problem. Let us see how. Suppose we have taken, this is a 100 mm long line. It's one end touching VP and other end in HP. Okay, one end in HP, other end in VP. Let us assume A is in HP, B is in VP, and A is in front of VP, B is above HP. That is the line. Now I assume the line in the entire line is in the vertical plane itself, not parallel. It is in the vertical plane itself like this. Let's draw a line at 35 degrees angle, that is angle with HP, and this is the true length of the line. Because the line is in the vertical plane, we see the true length of the line and a true inclination. So this is the coming to the top view of this line. The top view is obtained on the reference line here. So A1B1 is the top view of the line. I have highlighted this line because when you see this line in the top view, okay, and the point A will be in front of VP. So keeping the point B1 constant, this is a A1 B1, A1 dash B1 dash is the front view, A1 B1 is the top view, no doubt. Now coming to the top view, it is not like this on the reference line. It is A is in front of VP. That's why B1 as center, A1 B1 as radius. I rotate this point A1 so that the point A moves to the front side of a vertical plane like this. So I am rotating the point A like this. So this is the point A, which has finally come to the line perpendicular to the reference line. So this is A. What we understood here is the point A is in front of VP and it is at certain distance in front of VP. Okay, now let's assume, and one more observation we make is when the line is making 35 degrees angle with the HP, the point B is at certain height above HP, and this is the locus of B in the front view. Okay, now let's take the line separately. This is one set. I have drawn it. We draw it separately so that no confusion will be there. I take the line entirely in the horizontal plane, okay, and one end is in the VP like this. So I have taken the line at 45 degrees angle. The entire line is taken in the horizontal plane, making 55 degrees angle with VP. So what happens? The point B is in VP and A is in front of it. Okay, now, so this is A2, B2. If you draw the front view of this A2, B2, it will be on the reference line, A2 dash, B2 dash. Okay, the front view of this line is A2 dash, B2 dash, and just I am highlighting it. Okay, and one more observation here is the point A is at this much distance in front of VP, and you can draw the locus of A in the top view. Here we have drawn the locus of B in the front view. Here we are drawing the locus of A in the top view. Okay, now we'll do one thing. Point B is not in the reference horizontal plane. It is above the horizontal plane. So keeping this in the front view, keeping this A2 dash as fixed or center, A2 dash, B2 dash as radius, I rotate this point B2 upwards. How far? Until it reaches the locus. until it reaches the locus of B in the front view. We call this as B dash. Now, actually, this A2 dash, B dash will be the front view of that line, and this AB1 is the top view of that line. But because we have drawn separately, we did not get them in a line. But let us draw this separately. A is in HP. The point A is in HP. So A dash is on the reference line. So point A dash is on the reference line. And coming to A, it is in front of BP. So it is on this locus. So A is here on this locus. Okay. And here, draw a projector, right? We know that A is here on the reference line and the locus of A is this. So here, by taking the locus here into consideration, draw a projector from A dash onto the locus. You get the top view of A. Now, point B is when you see it in the top view, point B is on the reference line because it is on the BP. Now, the point B is on the locus here. So, B dash must be on the same projector, and from B, draw a projector here, and this is nothing but B dash. So, actually, if you see this A dash, B dash is the front view. This is nothing but the length of the front view here, what we get. Okay, there is no change at all. A dash, B dash is the front view of that line, and this is coinciding exactly with this. Similarly, this AB is the length of the line in the top view, and that is nothing but this AB. Okay, so because this sum of these two angles is 90 degrees, we are able to get these projections of this line in a line perpendicular to the reference line. So this is a very typical problem, and you can easily solve this way or in the previous method. It is up to you. Okay. Hope you had understood this problem very well. And if you have any queries or doubts, please do comment and do like, share, and subscribe. Thank you.